Hey everyone, and welcome back. Today we are going to tackle a real giant in the world of big data. I'm talking about a technology that completely changed the game for how we handle just massive amounts of information. We're talking about Hadoop. Okay, let's just dive right in with a puzzle. A simple but very real problem. Imagine you've got a single file. Maybe it's a huge scientific data set or a super high-res video. And this file is literally bigger than the entire hard drive on your computer. What do? How do you even store it? Well, here's the thing. The answer is to stop thinking about just one computer. When you're dealing with problems this big, the solution is to use a whole network of computers, a whole cluster, all working together as one giant system. And that right there brings us to what we can call the massive file problem. This is the core challenge that a system like Hadoop was specifically designed to solve. You've got to understand the sheer scale we're talking about here. This isn't just about a couple of big files. We're talking about millions of files, where each one can be hundreds of megs or even multiple gigs in size. And you need to be able to get to all of it fast. Now, you could try to build one single supercomputer powerful enough to handle that, but it would be just mind-bogglingly expensive. So a totally new way of thinking was needed. Instead of one perfect pricey machine, the idea was to store all this data across a whole fleet of cheap, and here's the key part, unreliable computers. Using hardware that you fully expect to fail sounds completely nuts, right? But it's actually the secret sauce to the entire system. So with that huge problem and this really radical philosophy in mind, it's time to introduce the solution that puts it all into practice. Enter Hadoop. Yep, this little yellow elephant is the logo for one of the most important distributed computing systems in the world. So what is it? Put simply, Hadoop is an open-source software framework that makes that whole many cheap computers idea a reality. It's designed from the ground up to build reliable and scalable systems out of unreliable parts. So how in the world does it actually work? Well, the foundation of the entire Hadoop ecosystem, the very first thing you need to get your head around is its totally revolutionary way of storing files. It's called HDFS, which, stands for the Hadoop Distributed File System. Think of it as the master software, the operating system that sits on top of all those computers and manages exactly how and where your data gets stored across that entire cluster. Now, HDFS organizes this cluster using a really simple but incredibly powerful leader/worker architecture. You've got one machine that acts as the leader, kind of like the boss, and then you have all these other machines acting as the workers, the ones doing all the heavy lifting. All right, understanding these two roles is absolutely key. The leader server is called the NameNode. You should think of it as the brain of the whole operation. Now, it doesn't store any of your actual data itself, but it keeps the master list. It knows exactly where every single piece of your data lives. Then you have the worker servers, which are called DataNodes. These are the muscle. They are the workhorses that actually store the pieces of your files. Okay, so let's walk through what happens. You send a massive file to your Hadoop cluster. The first thing HDFS does is automatically chop it up into smaller, equal-sized chunks, or blocks, usually about 128 megabytes each. Then the NameNode, the brain, tells the DataNodes, the muscle, where to store each one of those individual blocks. And just like that, your gigantic file is now broken up into little pieces spread across a ton of different computers. Okay, but wait a second. Remember what we said at the beginning? We're using cheap, unreliable computers. So what happens when one of those DataNodes just breaks? This is where the true genius of Hadoop really starts to shine. See, this is what's so brilliant. The system was built from the ground up with this one core idea baked right in. It doesn't just tolerate failure, it expects it. The fact that cheap, off-the-shelf hardware is going to fail all the time is a feature of the design, not a bug. So if you expect things to break, what's the plan? What actually happens when one of those data nodes just, poof, goes offline forever, taking a piece of your file with it? Well, the answer, the whole secret sauce, comes down to one little number, 3. This is the default setting, and it's what makes the whole system so incredibly resilient. Because Hadoop doesn't just store each block of your data once. Nope. It uses something called replication. For every single 128 megabyte block of your file, HDFS automatically creates copies,
3 of them in total, and it strategically places each copy on a completely different DataNode machine somewhere else in the cluster.
And this is why it's so ridiculously smart. If one of those data nodes dies, who cares? Your data is perfectly safe and available on 2 other machines. Hadoop is even smart enough to put the copies on different physical server racks. That way, if an entire rack loses power, your data is still safe. What you get is extreme fault tolerance, which means your data is always available no matter what. Now, reliably storing the data is an amazing trick, but that's really just the foundation. Let's kind of zoom out and see what else you can build on top of HDFS. Once your data is all safe and sound in HDFS, this whole ecosystem of tools opens up so you can actually use it. For example, there's MapReduce, which is a system for running massive computations on all that data in parallel. If you're used to databases, you can use a tool called Hive to ask questions of your data using a familiar language like SQL. You can even build a massive real-time database right on top of it all with something called HBase. HDFS gives you the storage, but these are the tools that really unlock all the value. Okay, let's boil this all down. What are the key things to remember? First, Hadoop lets you store massive files by spreading them out across clusters of cheap, everyday computers. Second, HDFS works with a brain and muscle. The NameNode is the brain that organizes everything, and the DataNodes are the muscle that do the actual storage. And finally, the secret to its reliability is replication. Making 3 copies of everything makes the whole system incredibly resilient to failure. So, there you have it. We've just pulled back the curtain on the fundamental technique that allows companies to store and access a virtually unlimited amount of information. The technology is here, and now you know how it works. So the only real question left is, what would you do with that kind of power?